Alright guys, today we're doing linear relationships test set 17. This is part B. This test is also 15 minutes, so let's try to do this in under 15 minutes and see how we go. Alright, let's get started. Match each table of values with an equation. So when you get a table like this, what you can do is find out what the y-intercept is first. Okay, so the y-intercept is 0, and then what we do is we find out what the gradient is. To find out the gradient, what we do is I'll write the equation up here. Oops. y2 minus y1 over x2 minus x1. That's the equation of the gradient. Okay, so this is y2 minus y1, which is 2, and then x2 minus x1, 2 minus 1, which gives us 2 on 1. So the gradient is 2. So the gradient is 2 and the y-intercept is 0. So what gives us y is equal to 2x? Sorry, is it 2? Y. Oh, sorry, y. I did it the other way around. So remember guys, the y values here, x values are here. Okay, x values are on top. So we do y2 minus y1 first. 2 minus 1 over 4 minus 2. What's 2 minus 1? 1. 4 minus 2 is 2. So the gradient is half. Which one gives us half? That's number 4, so we can write it here. Alright, next one. What's the y-intercept? -2. So we can write it down here. Actually, now that we have the y-intercept to be -2, we don't even have to do anything else because we know that this is the only one with -2. So we can write that already. These are some exam techniques that you need to cultivate, because if you find out a component of the answer and you can do process of elimination and eliminate every other answer, you don't have to do the rest of the question because you already know this is the only answer that you can get, and that's why you put it in. Okay, these are some exam techniques that you can practice so that you can finish your maths test in time. Okay, alright, let's have a look at this one. Question C. The y-intercept is 4. Let's have a look at which one of these equations have 4. This one does, so we can put VI as C. What's the y-intercept over here? 0. We've got a bunch here which has a y-intercept of 0, so what can we do? We do the gradient. y2 minus y1, so 8 minus 4 gives us 4. x2 minus x1 gives us 2 minus 1, which gives us 1. So the answer is 4. What gives us the gradient of 4 and the y-intercept of 0? That's V. It's 5. Okay, done. Next one. Y-intercept is also 0. Now we have to find the gradient. y2 minus y1, so 2 minus 1. And then x2 minus x1, 10 minus 5. What does that give us? 1 over 5. Which one has 1 over 5 as a gradient? It's this one. So that's I. 1. Okay, last one is this one. You don't even have to do it. Process of elimination. If you know what the answer is, don't waste your time doing the question. Just put it in. But I'll go through it with you just in case. We know that the y-intercept is 0 and the gradient will be y2 minus y1, so -8 minus -4 over x2 minus x1, 4 minus 2. What does -8 minus -4 give us? -4. -4 over 2 gives us -2. So the gradient is -2, which is F. Okay, F is the answer. Alrighty, next one. On the same number plane, draw the graphs. Okay, I'm just going to zoom in so that I can draw it properly. First one, x is equal to 2. So we start from here. That's x is equal to 2. Okay, always label your graphs. Next one, y is equal to -3. When it's y is equal to something, it's always parallel to the x-axis. And when it's x is equal to something, it's always parallel to the y-axis. Okay, so y is equal to -3, parallel to the x-axis, and we've got it there. Next one, x is equal to -3, so 1, 2, 3. It's not the straightest line, but that's okay. And -3. Okay, next one. Y is equal to 2, which will be parallel to the x-axis, like that. Okay. And we've got our lines. Makes a square in the middle. Very nice. Okay. Write the coordinates of point of intersection of the lines x is equal to -3 and y is equal to 2. So x is -3, so that's the x coordinate, and y is equal to 2, that's the y coordinate. That's the answer. Easy as that. Which lines are parallel to the x-axis? That would be the ones with the y's. Y is equal to 2, y is equal to -3. Which ones are parallel to the y-axis? Those are the ones with x. X is equal to -3, x is equal to 2. Done. Okay, I think it's the last question. Alright, complete the table of values for the equation y is equal to 2x plus 1. Okay. When x is equal to 0, the y value is 1. So we can put it there. When x is equal to 1, the y value is 2 times 1 plus 1 gives us 3. Next one, when x is equal to 2, what's the y value? 2 times 2 gives us 4, plus 1 gives us 5. So we can see that the regression is every 2. Okay, so we can go 5 minus 2 is 3, 3 minus 2 is 1, 1 minus 2 is -1, -1 minus 2 is -3. Now we need to draw the graph. Okay, we know that the y-intercept is at here, 0 and 1. At 1 it is 3, so over here, and at 2 it's 5 over here. So similarly, at -1 it's over here, at -2 it's over here. So the line goes something like this. Okay, it's not the straightest, but actually let's undo that. Hold on. Let's get rid of the line and draw it again. Something like that. Okay, it's not the straightest. You guys can draw it straighter than I could because you're doing it on paper, but this is what the line should essentially look like. Okay, where does the graph cut the x-axis? That's at here, -1/2 and 0. You can do it algebraically as well. Where does it cut the x-axis? It's when y is equal to 0. So we have 2x plus 1. So take 1 onto the other side. We have 2x. And x is equal to -1 over 2. So we can write -1 over 2, 0. Where does it cut the y-axis? We already know from here. It's 0, 1. And using the graph, solve for 2x plus 1 is equal to -5. Okay, using the graph. Where is it -5? 1, 2, 3, 4, 5. I think that's right. So 1, 2, 3, 4, 5. It's around here. Let's see where it is. 1, 2, 3. I think around here. I think it's at -3. Okay, we can do it algebraically as well, because if the graph is a bit unclear, we can do it algebraically just to double check if it's at -3. Okay, so we're solving for x. We take the 1 to the other side. So -1, divide both sides by 2. X is equal to -3. So that's the answer. And that's it, guys. That's test 17, part B for you.